Assalamualaikum and hi, we are from Group 1 here to present our lab report for Experiment 5, which is stability of floating body. This is our group member, Lim Zi Hui, myself, Norainun, Basyirah, Nurul, Afifah, and Afiq, Danial.
This is our table of content.
For the introduction, the stability of floating body experiment is examine what make a floating object stable or unstable in water. The experiment explores the concept of buoyancy, center of gravity, and metacentric height to determine the stability of a body when tilted.
So the objective of this experiment is to determine the height of metacenter using the tilting method.
For the theory part, the stability of the floating body is covered by the principle of buoyancy and the metacentric head principle. So for the principle of the buoyancy, an object which is submerged or floating, which will experience an upward buoyant force equal to the weight of the fluid it displaces, Fb equals to W. The buoyant force acts through the center of buoyancy, which is the centroid of the displaced volume of fluid. So the metacenter denoted as point M in the figure 1. So is the intersections point of the body axis and the line of action of a buoyant force. The tilting of a body can be caused by factors such as wind or wave action, leading to shift in the position of the center of buoyancy to a new location. So when the metacentric height is above the CG, center of gravity, and combined effect of the buoyancy force and the weight creates a riding moment. The riding moment will let the body to return to its original position, ensuring stability. But if the metacenter lies below the center of gravity, the body becomes unstable and cause overturning moment. So mg is the metacentric height. So if m is coincide with g and the body is said to be stable, which simply means critical. Based on the refer to figure 2, so we have an overturning couple and righting couple. So and equation 1 is the equation for overturning couple, and equation 2 is the formula for writing to calculate the righting couple. So for equilibrium, we know that overturning couple is equals to righting couple. Therefore, we combine it so we can calculate the distance of the gravity center to the meta center. So in this page, we have equation 4 showing the BM relationship with I and V. So BM is the distance between buoyancy center to meta center, and BG, equation 5 showing BG relationship with Y and D. BG is the distance between buoyancy center to gravity center, and then GM is relationship with the BM and BG in equation 6. So we combine it so that we can get equation 7 to calculate our theoretical GM. And equation 8 is the formula for us to calculate the least moment of inertia of Punton horizontal section taken at water surface. And equation 9 is the formula for us to calculate the volume. Equation 10 is we want to calculate the percentage error between the theoretical GM and the experimental GM.
So figure 3 is showing the experimental setup. We have the water tank, we have the thread, we have the vertical weight, we have the horizontal weight, we have the pontoon, we have the pontoon stabilizer, and we also have the ruler. For the methodology, apparatus was set up as shown in figure 3. The length and the width of the pontoon was measured. The total mass of the pontoon, including the vertical weight, and the mass of horizontal weight was measured. Mass of horizontal weight, total mass of pontoon, including vertical weight, length of pontoon, and width of pontoon are fixed variables. The horizontal weight will be removed. The first test was set at maximum height of the vertical weight. Second test will be at the middle of the vertical weight, and the third test was set at the bottom of the vertical weight. The center of gravity was determined by placing the pontoon mass on the stabilizer. The length of the CG, which is the distance from base of pontoon to the center of vertical weight, was measured. The horizontal weight was fixed, and the thread was aligned at the 0 mm position. The tank was filled with water, and the pontoon was placed inside the tank. The submerged depth distance of the pontoon was measured. The horizontal weight was moved 20 mm to the right or left, and the angle of tilt of the thread was recorded. The horizontal weight was shifted from 0 mm position in 20 mm increments until the plumb bob touches the pontoon. The horizontal weight was moved to the left in 20 mm increments, starting from the 0 mm position until the plumb bob touches the left side of the pontoon. Steps 2 until 8 was repeated for two different vertical height values, y1, y2, and y3.
Here our data result for degree of thickness and metacentric height.
Discussion 1. Plot the graph of GM with data and determine the value of GM from the plotted when data is given. So based on the figure 1, 2, and 3 for all the three tests for the right side, we can see that all the graph metacentric height This degree of tilt is increasing except for the third test. Even for the third test, it is decreasing, but we can see that it is slightly decreasing. This shows that as the degree of tilt increases, the metacentric height increases. And when the theta value is equal to 0, GM is equal to 0.043 for the first test, GM is equal to 0.061 for the second test, and GM equal to 0.09 for the third test. Next, based on the figure 4, 5, and 6 for all the three tests for the left side, we can see that all the graph of the metacentric height GM, this degree of tilt are increasing. This shows that as the degree of tilt increases, the metacentric height increases for the left side. And when the theta is equal to 0, GM is equal to 0.032 for the first test, GM equal to 0.061 for the second test, and GM equal to 0.064 for the third test. We can see that the value of GM when theta is equal to 0 on the left side is slightly lower than the right side.
So for table 2, this is the list of experimental metacentric height. So part 2 is we calculate the theoretical GM using an area of second moment I. So equation 8 showing the formula for I. So we have table 3 showing the fixed variable, and we have equation 9 to calculate the volume. So we use the fixed variable to calculate the moment of inertia and the volume of display by ponton. So for this part, we can calculate the theoretical GM by using the area of second moment, since we have calculated the area of second moment and the volume, and we have also measured our center of gravity, which is Y, and also depth of submerged ponton. So we can use equation 7 to calculate our theoretical GM. So we can, based on the tables 4, we can see the test 1, test 2, and then test 3, the comparison of the center of gravity and also the theoretical value for GM. So we found this trend, which is, we found this relationship, which is when the value of gravity, center of gravity Y decreases, metacentric height GM will increase. And also we found that when the center of gravity increase, the submerged of depth also will increase too. In this page, we discuss about the percentage error of theoretical GM and the experimental GM. So we have experiment GM, we have two values, which is one we tilt it to the left and another one we tilt to the right. So we found that for the left hand side, the percentage error is higher than the experimental GM tilt to the right. So for the table 5, we can see that the theoretical GM with experiment GM tilt to the left, the percentage error for the first test is 82%, which is very high, and the lowest percentage is in second test. For table 6, we can see the theoretical GM, and the experiment GM percentage error is overall is lower compared to the tilt to the left hand side one. So the lowest percentage error that we get in the experimental GM tilt to the right is 27.44%. Since we get quite high percentage error, so some of the measurements shall be considered, which is to prevent the parallax error. So first is we need to perpendicular to the reading, and then also we need to, sometimes we need to concern about the vibration of water, and also we need to improve sometimes about the fan well causing the ponton tilt more. And also we need to make sure that when we read the data, the thread hanging on the plumb bob is in a correct position.
So for discussion number 3, the stability of a floating body like a ship depends on the relationship between its center of gravity and metacenter. So center of the gravity is where the weight of the body is concentrated, while the metacenter is a point that indicates how the body reacts when tilted slightly. If metacenter is above the center of gravity, the body is stable and will return to its upright position after tilting. If they are the same height, the body remains tilted. The distance between metacenter and the center of gravity, known as metracentric height, GM, determines the degree of stability. A larger GM will make the body more stable, but it may cause it to roll uncomfortably in waves. A smaller GM reduces stability, making it more prone to tilting. To enhance stability, ship designers keep the center of the gravity low by placing heavy items lower in the hull, ensuring metacenter remains above the center of gravity in all typical conditions.
For the last discussion of the experiment, we also discussed the effect of variation in angle of tilt on the position of the metacenter. The first one effect is on small angle of tilt. The shape of the submerged part of the body doesn't change much. This means the center of buoyancy move only a little, so the metacenter stays steady. If the metacenter is still above the center of gravity, the body will automatically straighten itself. The buoyant force acts to restore the body to its upright position. The second one, large angle of tilt. The submerged shape changed a lot. The center of buoyancy moved further away from the center of gravity, which affect the metacenter. The metacenter can shift downward as the angle increase. If the metacenter below the center of gravity, the body can stabilize itself and may tip over completely. This happens because it changes the underwater shape of the body. This shift change where the buoyant force at, which affect the position of the metacenter.
These are the safety procedures that we applied during the experiment. First, handle water carefully to avoid spills and slipping hazards. Secure the floating body to prevent it from tipping suddenly. Avoid loose clothing, injury, and tie up long hair. Wear appropriate personal protective equipment (PPE) such as lab coats, gloves, and closed-toe shoes. Make sure there is no wind or disturbance when conducting the experiment, and make sure eye is perpendicular to the reading of the ruler to get the accurate reading and avoid parallax error. In conclusion, from this experiment, we can get the value of metacentric height by using the tilting method. To get a more precise value, there are errors that need to be avoided, such as the parallax error and the disturbance in the water tank. Make sure the eye is always perpendicular to the reading of the instruments and turn off the fan to avoid any movement of the pen tube.